We can see, we can tell the farmers, if he see this maps, hey, you have to go to this area, you have to apply more nitrogen. And not only that, not only the location, but it can tell him that how much of the nitrogen needs to be applied. Then this one, we introduce the model inputs and the feature selection. In the left side, you can see we summarized our inputs to 3 categories. We have vegetation indices based on the chlorophyll index, water index, and also the dry matter index. And also we have agronomy. This is related to the nitrogen rates, days after emerging, and different varieties. We have also environmental variables, the accumulated temperature, precipitation, and different factors of environment. In the right side, we have the figures that can assess and evaluate the combination of those inputs, how they are related to the butyl nitrate and also the total yield for potato based on the R-square, the coefficient of determinations. High R-square meaning those inputs is related to the, to can predict the yield. Less meaning, the model is not performing well. As we can see, combining of all of them, it can give us almost like till 0.8, which is kind of strong model. While once we have just only the vegetation indices, the model it's like performing weak. So that can tell us it's very important when we do the prediction, when we create the prediction models, we have to come up with the genetic, we have to come up with the environment, and also with the management as well. So this one, it's moving to how we creating the machine learning models based on the different years. As we can see in the top 3 figures, this is actually the training models, and the lower one based on the validations. Based on just like the non-fertilized applied, then we do the validation based on the fertilized. What we can see here, it's the rate shifting. Can tell us that the model actually predicting the shifting of nitrogen, even though when we applying the nitrogen, how that's shifting. And this shifting can tell the farmers that, hey, when you do the applications, this application can contribute more to the actual. It can like give you more yield. And when it's shifting down or maybe less, can tell the farmers that even though you do the application, that will not contribute to the butyl nitrate. Similar for this, but this one, we just like having 2 different kind of applications, 2 different kind of the nitrogen applications. For this one, it's actually related to the tuber yield. We try to like predict the end of the season, how the yield is. So the first 3 figures, it shows the training models, which it can show us a very strong based on the indicators, statistical indicators, R-square, coefficient, and less error as well. Then the down show us like how the validation of these models. Again, once we have like this red shifting based on 1-to-1 baseline, it tells us that when we do the applications that contribute to the yield. So it can tell the farmers not only that, but it can tell them how much of the yield contributions. If they apply much, is it contributing much to their yield or maybe less? So that's the information we give to the farmers. Similar for this. So to conclude from this study demonstrated how strong spectral and AI can be contributing to the beet yields, to the yield, and also how the different machine learning models can like give us the high performance. And also not only that, this one contribute to the precision nutrient management, to reduce the environmental impact, and also to increase the agriculture sustainability. What we are trying to do is to adapt this one to the different crops, because different models like training based on one crop. So we try to see like how this can be adapted and be used to the different crops, and also how can be like integrating with some other tools like robotics to do at the real-time decisions, as we are moving from precision agriculture to the smart agriculture 4.0, where the devices, the technologies can do everything for us from A to Z. So this one just to show that these studies have been, published in a very high journal, like Smart Agriculture Technologies. So more information can be found there. Some of the studies just like under review right now. With that one, I would like to thank all of you for attending till the end of the day. I would like to thank the committee of ARD. I would like to thank Dr. Des for, contributing to this. So, any questions? Yes.
What are the models that you are using for
The machine learning models? I applied almost like 11 different models, but what we can see here, it's like random forest. Yes, because of the short time, but I applied random forest, I applied XGB post, I applied support vector machines and some other things.
And you use the data as you collect the data, hyperspectral data, but you process it in the form of CSV data, or is it like tabular data? Or
what do you mean tabular?
Do you use imaging or
Oh yes. The process of hyperspectral, you collect the image, but after that's for the machine learning, it's different from deep learning. Deep learning, you feed the data, the models, the image themselves.
Mm-hmm.
But for machine learning, no, we do the extraction.
Yeah.
So we do the extraction based on each plot, based on each plants. That's why we need to calculate the NDVI to tell us, the spectral, this is coming from the plants or maybe coming from the soil. Yes.
And did you get to check